So moving into kind of really understand and look at this from a troubleshooting performance perspective, really what Acori can help you do and what balance point our product can do is really reduce troubleshooting time to minutes. What we've had is an understanding that you can map front to back. It's really the wow factor that you get day one, sometimes in as fast as 45 minutes for your data center, understanding what are the different things that are connected together, what are the elements that are mapped together from the app to the server to the storage, and really giving you a color-coded key that says, hey, here's your bottleneck. In our world, red doesn't mean dead, red means there's a bottleneck. Helping you drill down for deeper analysis so that you can quickly understand, okay, here's where I have a point of contention. Maybe one you didn't even know existed. Maybe one that's not bad, but understanding still the same, that you do have contention there, you have utilization, and what is it, good or bad. So helping you understand and model that and the application's performance across that. So looking at that infrastructure response time, looking at it from a CPU perspective or an I/O. As my CPU transactions go up and my I/O rate goes up, what happens to my overall response time? Well, maybe my CPU stays about the same from a response time perspective, but my I/O goes off the chart. What's causing it to go off the chart? Being able to drill into it, understand it, and get a better view of what's going on. And really understanding, am I efficiently using those resources or am I not? In VMware, they have the whole idea of percent ready time, really, which is telling you, are you waiting or not? What is your max ready time? Really doesn't tell you if you're efficiently using it. What we mean by that is, am I getting high utilization? It's a fixed asset again, be it a virtual fixed asset, or am I waiting and I could be doing more? So understanding if I have 2 CPUs, but I have a 4, and it's a 4-core box, I have to wait for 2 of those cores to come open. Am I waiting? How often am I waiting? Is it slowing my utilization down? And looking at, I could be running faster, I could be running more efficiently if I tuned all the others that are on this system as well. Really getting into a better way of letting you know, is the CPU allocation, or can I go reclaim some of these resources? One of the case studies that we really like to talk about is one of our customers, Service Corp International. Really what they were looking to do is, they had a fixed budget, very lean organization, virtual first, looking to really do best practice consolidation, but really migrated as is. And what ended up happening is they had phantom slowdowns, a lot of finger pointing and really a lot of chasing their tails. What happened when they put the balance point solution in was really the topology highlighted some of the bottlenecks and configuration problems that they were experiencing. Things that were done because, hey, this is the storage we had available. We caused us to go and take a LUN from that RAID group. Did not really understand, okay, is this the right I/O patterns to be on that array? What they were able to do was really go back and relay out, both from a CPU, a memory, and an I/O storage perspective, here's what lives together. What they were able to then do is really lower the amount of time that their admins were spending troubleshooting and fighting fires, and really more time planning. This also allowed them to achieve that 300 to 1 consolidation ratio without burning out their staff. So a lot of what we see happening is being able to do this without burning your staff out, without really having to augment or add staff, keeping things very flat but doing more with less, by not having them chase their tails and really get involved in this. So once you've done that, you've now relayed some stuff out, you've relieved some bottlenecks that have caused you problems, you really want to optimize that performance. So understanding, okay, I got rid of that, the hair on fire, the guy who was complaining, well, how do I get rid of proactively the next guy who's in line behind that guy and understand, okay, before it becomes a problem, how do I get that? So looking at and improving density. So as you deploy from 1 VM to 2 VMs, and as you start to move up a gas gauge, providing that gas gauge that says, hey, this is where you are. Really, how close to optimal are you running? If I get the 4 VMs on this particular server, those 4 VMs are using 100. That's optimal. That means all of the resources, CPU, memory, and I/O are effectively being utilized. How do I know that when I add that fifth, that I start to fall off the cliff? and response times suffer for the VMs that are on there. Well, understanding if as I back out and vMotion back, what was the one app that pushed me over that? So looking into the VMs themselves and understanding, here's the heavyweight VMs. They're using more of their resources or less of their resources. Understanding and paring back resources so that you can fit more onto those ESX servers. So giving you not only the gas gauge within the ESX server, but a gas gauge within the VM so that you can best justify, okay, here's who's using what resources, here's a number. It's at 30. They're using 30% of what we've allocated from a workload perspective. And we've charted this over 3 months. And we know that they've never spiked beyond 60%. So what we're going to do is give them 50%. We're going to go cut it in half. They'll get their overage, and we'll be able to get higher utilization of those resources. This is really critical to being able to enable what Nexus was talking about with their private cloud initiative, as well as the VDI or the virtual desktop initiatives that are out there, and looking at how do I understand what is the workload, because especially when you get into desktops have very random workloads. You may have people who have scripts running on there that actually do sysadmin privileged type things. You have people who have application owners who are doing, ETL type applications, and you may see different scenarios as you roll out. What used to be isolated out under their desk is now in your data center. How does it perform? Do they have enough resource? Who are the ones who need those fast processors and such? Looking at that and quickly identifying configuration capacity issues, understanding are you across what you're really entitled to. So on this whole idea of, well, you get what you pay for. So I'm entitled to a certain service level if everybody gets busy, if I have a giant pool of resource, and I'm not, putting on CPU limits or CPU reservations, but looking at it and saying, hey, if I get busy and if everybody else gets busy, this is what I'm entitled to. So before I get into a scenario where I have great utilization and everybody is busy, understanding where will that push me down to? What is that theoretical entitlement versus what is the hard limits that are set? And understanding, do I need to go back and set reservations and things of that nature? What we've seen is people utilizing this and quickly moving into and understanding how these resources are allocated. One of the ones that's pretty effectively utilized this is Vistaprint. They kind of had a one-size-fits-all, we're going to keep deploying until people complain mentality. And what they did was, people complained a lot, and they wanted to get out of this, and they really wanted to provide higher densities within their infrastructure, get to that second level of ROI. So they were getting, 45 or so VMDKs per data store. But every data store was a RAID 5 data store of a certain amount of disks and a certain, terabyte limit. And what they wanted to understand is why in some disk groups or data stores were they able to get 45 and others only 36. And when they would go to 37, they would have contention. And why wasn't it all the same? So looking at it, utilizing some of the graphing technologies as well as the scorecards that highlight our key performance indicators, really looking at, okay, I need to be able to understand what VMDKs are I/O intensive and which ones are not. I need to be able to get higher stack ratios in some data stores, lower in others. Maybe I need different RAID types, a better mix of I/Os as well. You're going to have a lot of random I/O per data store, but looking at what percentage is read versus write versus where it's coming from is also very important, so you get those right mixes and understandings. Then looking at an I/O performance monitoring and really getting those higher densities was really the result. They were able to save themselves money both on the storage side as well as on the ESX server side. So once you've done that and you get this baseline and now you've saved yourself from having to add more to solve problems, really looking at, okay, how do I plan